can properly get into the presentation. So again, thank you very much for having me. I'm Miles Harrison. I'm excited to present on natural language processing at scale with SparkNLP. I am building an accelerated training program in natural language processing, large language models, and generative AI called NLP from scratch. And those are the different platforms that I am currently on there. So if you want to check out any of those or tag or share anything that we're going over today on social media, all the handles there are just at NLP from scratch. Okay, so we're going to talk about NLP, we're going to talk about Spark, and we're going to talk about doing NLP at scale. So before we do that, just a short disclaimer. SparkNLP is mainly made by John Snow Labs, and Spark is obviously an Apache Software Foundation project. I am in no way associated with these organizations. I am not speaking on their behalf, and everything I'm presenting here is my own views. If there's any mistakes, I apologize. It's not intentional, and this talk is not sponsored by John Snow Labs or the Apache Software Foundation or in any way affiliated with them. This is just me presenting my POV on it. Okay. So with that, we can move forward into the presentation. Just a quick introduction about what we're talking about. I'll talk a little bit about what natural language processing is for those that are not familiar, and I'll also talk a little bit about large language models and the hype around it that we've seen recently. Then we can dive into the particulars of what SparkNLP is, short demo and code in the Colab notebook, and then I'll talk about some future directions and recent stuff, and then we can conclude and wrap up, and then also have questions. So just quickly, once again, I'm Miles Harrison. I'm a data scientist. Prior to what I'm doing now, I was a career consultant at companies like Sapient Nitro, PwC, and Accenture. I also led globally a team of data science educators at a tech boot camp with offices in New York, Vancouver, Toronto, and London, and did that for about 4.5 years, helping both deliver that program and also develop their curriculum. Now I am doing my own thing with NLP from scratch, but my passion continues to be teaching data science, machine learning, and AI. Okay, so let's talk about natural language processing, and we'll also talk specifically about the NLP use cases that we're looking at here, or specific task we're looking at here today. So if you don't know, natural language processing, or NLP, is a domain that lies kind of at the intersection of linguistics and computer science and lately artificial intelligence. Though this does have the word processing in it, which when people hear that word, they think of processing, manipulating, filtering data. Really any sort of data, computational, machine learning, AI problem involving natural language, that is the language that we work in every day and speak and write in as humans, is referred to as natural language processing, because you do have to do processing of that information in order to even do things like machine learning on it, okay? So it's not just manipulating the data, it's working with doing machine learning, doing AI, all these things, statistical analysis of text, all these things are considered part of the NLP domain, okay? And I'm sure many people in this virtual space have heard recently about large language models, or LLMs, which are all the hype recently, thanks to this thing that got released in November of 2022. And these currently represent the state of the art in natural language processing. So speaking a little more about large language models, or LLMs, as I said, ChatGPT really disrupted the whole space, as well as, I would just say, the broader world at large. So large language models are a specific type of deep learning model or neural network that works with language and are both very large in size in terms of their number of parameters, but also very, very large in terms of the size of the data sets that they were trained on. And these data sets are usually just very, very large volumes of text. We're talking about, double-digit percentages of the internet. So when people talk about large language models, they're usually referring to things like GPT, which generate text, though there are multimodal models that do things like work with images and text, or video and text, or even audio and text. And the vast majority of these are based on the transformer architecture, which was introduced by Google Brain in 2017. So much so that many people use the term large language model and to almost mean the transformer architecture. They almost use the terms interchangeably. Okay, so that's just some backgrounds on LLMs. We aren't going to really work a lot with LLMs today, but I'll talk at the end about kind of how SparkNLP is now able to use these things, and we'll see a little bit an example of using one for embedding. Okay, and that being said, just a reminder, I put, as Meredith knows, I put this slide in almost every single presentation I give. Just a quick reminder that this is the Gartner Hype Cycle for Artificial Intelligence for 2023 as of August. And we are still precisely here since August. Generative AI is in the absolute peak of the hype cycle. So bear that in mind as we talk about AI and large language models and things like that. There may be a trough of disillusionment coming very soon for that. Okay, I say this as someone that works in the space. We're all aware. Okay, so how do we do NLP? If you are working in NLP, at least in my experience, these are some of the tools of the trade that you will be working with. You are almost assuredly working in Python if you are doing data science work in NLP, unless you're some sort of more DevOps or machine learning engineer type focused role. As part of that, you're probably working with Jupyter notebooks for reproducibility and also just to document your outputs and what you're doing. The Natural Language Toolkit, or NLTK package, was originally developed at a university to help with teaching NLP, but it's so well made that it's become a fundamental and absolutely core tool set in doing NLP work and is part of a lot of NLP workflows. We also have Pandas, which is just a library for working with general structured data and doing data analysis work in Python, but it has a lot of utilities for text processing and working with string data. Spacey in the middle there, they say on their website that it's industrial strength NLP, really intending to do NLP in production and build product at scale with NLP. So that's another library. GenSim below that is not as general purpose as Spacey and is really used for doing what is called topic modeling and more of these types of unsupervised learning types of approaches. So the GenSim library is a bit more specialized in that way. sklearn, basically the standard for open source machine learning, does all kinds of machine learning and working with data and features and all these things. But obviously, as part of that, it also does things like NLP problems and has a lot of great utilities for text preprocessing. And then in the deep learning domain for neural networks, we have PyTorch from Meta or TensorFlow from Google. So pick your flavor of evil. Just kidding, kind of. And then Keras obviously recently makes TensorFlow a lot easier to work with and has been part of TensorFlow proper since TensorFlow 2.x. And then recently, very recently, we have in the large language models domain, the startup darling Hugging Face, which is basically, amongst other things, they've written libraries which are sort of a higher level APIs on top of these deep learning libraries to work specifically with LLMs. And this is sort of becoming an open standard for doing work with large language models. Okay, so that's the toolkit. This is a very much non-exhaustive overview and visualization of the different types of tasks you can do in NLP in the different domain areas. So we see things like translation, machine translation, things like classifying documents, multimodal NLP, I already talked about. There's a whole world out there of NLP. Today, we are going to cover a very, very small subset of a few of these tasks, which I have highlighted here in black. So we already talked a little bit about LLMs, and I'll come back to it. We are going to be looking at the task of named entity recognition today, and I will explain in a second what that is. And then as part of doing that, we do need to talk about text or word embeddings, and I will now explain what text and word embeddings are for those that are not familiar. Okay. So the very simple answer to what a text embedding is, if you need to Eli 5 or explain it to your grandmother, a word embedding is just a way of representing text information as a number, all right? It's just any sort of way of taking text and representing it numerically, because numbers are what computers understand, and we need numeric data to do things like machine learning, all right? So you're taking different pieces of text, different words, across a corpus and then encoding their meaning by either looking at statistical properties of the corpus or in recent cases having some sort of model which would generate an embedding based on some sort of NLP task that the model is trained against. Even, OpenAI or companies like Cohere, Anthropic, they have embeddings that they have that come out of their own models. So here you have an example, the words man and woman are going to be, kind of related to the terms king and queen. And maybe these things are all sort of close together or directionally similar in an embedding space because they are semantically similar. That is to say, they have similar meanings. Okay, and today what we're going to work with is the glove embedding, which is just a simple statistical embedding that looks at the co-occurrence of tokens across very large bodies of text from the internet. It's quite old now, it's from 2014, but it remains kind of, a standard and basis sort of embedding for when you're just, doing walking around type of work. Okay. And so the task we have chosen to do today with SparkNLP is named entity recognition, or NER. And this, as the definition would imply, is the task of identifying named entities. And you can look up what a named entity is from the link. I'll make these slides available later. But basically, it's the who, what, and where of something that occurs in text. So if you have a piece of text, people, places, things, and then also things like numbers or quantities or dates are different things you can identify, right? So in the example below, if you just give the computer this text, identifying that the tokens, the words Elon, Reeve, Musk, refer to a person, that is an example of named entity recognition, recognizing that that thing is a person. And we see other named entities in this little snippet of text as well that the model can identify and sort of tag those individual phrases or words. So that's named entity recognition. Building on named entity recognition, we also have named entity resolution. And this is different because you need to distinguish between ambiguous entities based upon the context. So, for example, on the right there, I have a picture. We have a statement. General Washington rowed his boat with his men to the center of the river that flowed through Washington state. An example of named entity resolution would be understanding that in the first case, Washington refers to a person, George Washington, and the second refers to a geographical place, which is Washington, right? So these two things are different. And that's an example of named entity resolution. And if I've made a egregious error when it comes to American geography, I apologize. There's another task called named entity disambiguation, and this is usually meant to take an entity once you've identified it and then tie it back to some sort of data source or knowledge base specifically. And this is an example of what you call entity linking, all right? So these things build on named entity recognition. First, you have to recognize it, then you have to make sure you know which it is, and then ideally you want to tie it back to some sort of data source. Confusingly, named entity recognition and resolution both have the abbreviation NER. And then on top of that, if you look in the literature and online, people use the terms disambiguation and resolution almost interchangeably. There's a lot of blurring and overlap between the two, and it's not clear exactly which is which I find super annoying. So in practice, you can just talk about all these things together, and then they have a nice, neat acronym of NERD. Okay, so how do we do NLP? And now I just realized that I messed up the animation on my slide, and now I said that aloud, so it's in the transcript. Very embarrassing. Anyway, NLP in practice, typically you have your laptop that you are working on as a data scientist or some sort of other technical role. You add a bunch of Python to do the NLP work that you want to do with the toolkits that I already mentioned. And to do that, you need a whole bunch of text data that you are working with, a corpus of documents as they are called. And then the other important thing you need to actually get some good NLP work done is lots and lots of coffee and blood, sweat, and tears. So when you put all those things together, you get a good result at the end. And for a really large amount of NLP work, I believe that this is really the formula that people are working with. And then reality sets in, because in reality, you go to an organization or you get a project that is significantly sort of, shall we say, quote unquote, real. And then you have a corpus of data that you sort of prototype on and are building on top of. And then you realize that there's really a lot of text data out there. There's reams and reams and reams of text data. And all of a sudden, your MacBook, even if it's very expensive, starts to catch fire and take off the runway and become a space heater for your home because you no longer have enough RAM and memory and computing power to actually tackle these NLP tasks because they get quite computationally intractable fairly quickly. And so all of a sudden your job has just become difficult and a big source of anxiety. So I have personally seen students experience this very thing happening. And this is the motivation for doing NLP at scale. And that will segue nicely into the next part of the presentation where we talk about SparkNLP and also a little bit about Spark. I am assuming that a large percentage of the people here in this meetup already are quite familiar with Spark, but if there are folks that are not, I am just going to take a little time and talk about Spark briefly to introduce it. So Spark is basically the standard for doing big data work and working with large data sets in a distributed way. You can work in many different languages to work with Spark. You can also, they were very smart when they developed it. You can work on a single machine and then take your code, move it to a cluster, and without really changing the code, it will work in a distributed way as well. So it makes doing development work a lot easier. Interesting pieces of history. Spark was developed out of work at UC Berkeley by Matej Zaharia, who is now the serving CTO of Databricks since 2013. And Databricks really is the one, even though Spark is open source, Databricks is really the one that has driven its development and remains basically, you know, sort of the face of Spark. Okay, so looking at the Spark infrastructure and the different pieces of it, we have Spark Core, which is the underlying pieces that make Spark actually work. Again, very flexible. It's by default, it's built in Scala and they expect you to work in Scala, but you can also write code in Java and Python and PySpark, which is very common now, and then perhaps less commonly and less well supported, but it is possible to even write code in R and work in Spark in R. And then we see the other pieces of the Spark architecture. You have Spark SQL, which is working with data frames, and you can even do things like write SQL code and have the Spark engine execute it to do different tasks on large data sets in a distributed way. Spark streaming for working with real-time data. So we're talking about data sources like Flume and Kafka and things like that. Very mind-bending if you get into a lot of that type of real-time work. And then the other two pieces, MLlib, the machine learning library for distributed machine learning in Spark. Lots of different algorithms here implemented in a distributed way for doing machine learning at scale. In my experience and my knowledge, this is very criminally underused in industry, even though it is there. And then we have GraphX, which is for working with graph data. If you're doing something like social networks or financial transactions, financial networks, or power grids or something like that, they have this type of capability built into Spark as well. And the other amazing thing that I think I touched on already is that Spark works with a very large number of different data sources, obviously Hadoop and the Hadoop file system, but also things like Kafka for real-time, Cassandra for high throughput as well, and our favorite object stores from different cloud computing providers, whether that be GCP or AWS or Azure. And there's a very, very large number of different sources that Spark works from, so it's really amazing how flexible it is in that way. And then finally, just wrapping up here with a bit of a history lesson, the key difference between Spark and Hadoop and where we all came from is that Hadoop works on disk and Spark works in memory, which makes it much faster. So it's all based in RAM when it does the distributed computing. And then the other part of the history lesson that is more close to my heart, but also slightly more painful, is that in the bad old days, we had a lot of people in large organizations trying to do things like make on-prem data and work with all their own infrastructure and manage all of it, which a lot of very large organizations are not so good at because they are not technology companies. Things started to get a little bit better when we had this thing called Hadoop come around, and people started to move towards both managed Hadoop, but then also things like hybrid infrastructures and gradually moving towards cloud. And now, hopefully, things are a lot better and easier with Spark basically being a standard and us having infrastructure as a service, software as a service, platforms as a service, through these providers that we know and use. Although now, obviously, we are, beholden to these large, horseman companies that run tech in the cloud. So if you want to do work with Spark, for Google Cloud, you have Dataproc. For AWS, you have EMR to do that. And then I believe Azure used to be in the old days HD Insight. I think now, because of their very, very close relationship with Databricks, they are pushing everyone to use Azure Databricks, and the relationship between Azure, Microsoft, and Databricks is very strong. And I will also just take this time to mention that there is a lot of money in that domain. Always interesting to talk about companies when you talk about billions of dollars with a B. That's Databricks, so no shortage of work in that regard as far as I'm aware. Okay, so that's a good refresher on Spark, which will lead us next to talk about everyone's favorite show, which is Game of Thrones, and this gentleman who knows absolutely nothing and is very cold. No, not that Jon Snow. I actually want to talk about the other Jon Snow, who was a famous English physician from 1813 to 1858 in Victorian London. And he is widely viewed as a pioneer of anesthesia and just medical hygiene in general, and also viewed as the father of epidemiology and germ theory. Because before Jon Snow, a lot of people had this miasma theory, where disease just sort of spread through this bad air in clouds, and people just got sick kind of more or less randomly from these miasma. But what happened was there was a cholera outbreak in London in the mid-19th century. And, people didn't really understand how germs spread, but Dr. Snow, I guess I should say, he was one of the first people to do advanced data visualization analytics, and he made this map of all the different people that got infected with cholera in this neighborhood. And he showed that everyone was getting sick from one contaminated water pump, and that's where all the cholera was coming from. So he was not only sort of a father of germ theory by showing that cholera was actually waterborne, not from this miasma, but he also was a pioneer in using data to uncover insights and using visualization and things like that to tell a story. Okay, so this is sort of the motivating figure who gives his name to Jon Snow Labs, which is the company that creates the SparkNLP product. So Jon Snow Labs was founded in 2015. They primarily deal with NLP, data, and AI, and they have Jon Snow as their namesake there because they primarily work with healthcare clients and clients in medicine and pharma and things like that. All right, so SparkNLP is open source. It's a product they make, but it is open source, and it's built on top of Apache Spark and SparkML. It's been out for a while now. It was released in 2017 and widely used in industry. And as I said, a lot of unstructured text data and natural language data in the medical domain. So it's used a lot in the medical domain, but it's also used across multiple different verticals. And we'll talk about this a little bit later, but we're now seeing them continue to update this and be on the cutting edge of NLP by having it work with things like LLMs and these generative models and things that are very much the cutting edge. Okay, so once again, I am not sponsored with or sponsored by or affiliated with Jon Snow Labs, but here is a slide, that they have on their website talking about how much SparkNLP is used. Basically, my impartial viewpoint is that yes, it's a very, very common toolkit. As far as I know, it's one of the only real ones for doing NLP on big data at scale. And so it's basically the standard. And they're showing here that, a third of organizations surveyed use SparkNLP inside of their natural language processing or just general machine learning and data toolkits. That being said, I did go back to the sources, and one of these surveys was actually sponsored by Jon Snow Labs. So take some of that with a little bit of salt. But nonetheless, it is true that it is a pretty standard toolkit for doing NLP, especially at scale. All right, so that's Spark NLP, and now we can apply it to a particular use case, a particular task, excuse me, in NLP. And let's talk about some of the bits and pieces of Spark NLP and how it works. So here we're going to apply named entity recognition using Spark NLP. And there's a few different types of classes we want to use. One is called a document assembler, and this is just to put things into a document format by doing what is called annotation. So Spark NLP is for identifying the different documents of text. Once you have the different documents, then you have a tokenizer which goes through the different documents and splits up the documents into different individual words. And then on top of that, we're going to apply a word embedding model to have numeric representations of the text. So I already mentioned what word embedding models are. There's different classes for this in Spark NLP. And then finally, we're going to apply a named entity recognition model, which in Spark NLP is NERDL. And this is used, there are a variety of different models you can use, but this is used to apply models for named entity recognition to the different word embeddings to tag the different pieces of the text. Okay, so these are the different classes we're going to use in the example I have today. And just by way of visualization, there's all these different classes that do different things, but what you typically do, this is not for the NER case we're doing, but what you typically do is string these things together step by step into a kind of pipeline. And then you go all the way from your raw data of sort of unstructured text into your final result, whether that be a model or what have you. And so here I'm going to walk through each of the individual steps and each of the individual pieces of a pipeline to show how the different Spark NLP classes work and what they do. And then when we're at the end, we'll just show the application of a pipeline, which is a bit of a more higher level abstraction, and just how little code you need to write to do something like, you know, get a word embedding or fit a classifier model on text or something like that. All right, so that already brings us to our demo. So now I am just going to kick myself out of these slides and take us over to the notebook here. And here's the notebook. And the first thing I'm going to do is just spin up the Colab instance that backs this. We don't need to use GPU or anything like this. Again, I'm just going to be demonstrating very simple usage of Spark NLP. Because this is kind of a hello world example to show how these things work. I did have ambitions to do some, you know, grandiose, you know, billion row project on GCP or something like that, but I figured with the time constraints, we would just show how the different pieces work today. So on the plus side, you can just install PySpark and Spark NLP locally and actually run them on Colab in single machine mode. It's not a big deal. So we can just do that using pip, and there's nothing fancy that is needed to be done there. There's also a setup script that is provided with Spark NLP specifically for Colab, and you see them use that in some of their example notebooks as well. Now we're going to start the Spark session, which is something you normally do with Spark. There's actually, if you look at the documentation for Spark NLP, they actually provide a helper function to do this, but I'm not sure if this is any different than just sort of using a regular Spark session through PySpark. But anyway, you can call it through Spark NLP. They have a helper method to start the Spark session if you're specifically using Spark NLP. All right, I'm really just talking this much to kill time while this cell actually runs so we can get going with the demo. Okay, so while we're waiting for that to start the Spark session, again, we're going to be doing named entity recognition. Here we're going to be identifying named entities in a body of text, which is our corpus. So if we have a sentence like Elon Musk is a businessman, question mark. Elon Musk is a named entity, and the task here is to identify that those two tokens together are a named entity of a particular type, right? We don't want to say that Elon Musk is a country or something like that. Did this run? Okay, it's run, so we're ready to go. Okay, so here is our pipeline. It's going to be a little bit different, but we're going to use the document assembler. We're going to use embeddings, and we'll see what each of these things does. And it's not really that complicated when you look at sort of a data level at what they are doing. I'm just going to zoom in another level here so this is bigger. So here I'm going to set up my data. Again, this is a very toy hello world example. So I'm literally just taking 3 sentences. Elon Musk is a businessman. Joe Biden is president. Sam Altman is an entrepreneur. and then putting that into a list, then putting that into pandas, and then because I'm lazy, converting the pandas data frame into a Spark data frame with huge big data of exactly 3 rows. So we just have this single column Spark data frame of 3 rows of text. This is our corpus that we're going to work with. So now with just a few lines of code, we can use the document assembler. So from the base in SparkNLP, we import the document assembler class. Then we set an input column, which is text. We set a new output column. And then literally all you do is call document_assembler.transform on your text data frame. And you can see that all it has done is appended a new column to the Spark data frame called document. And if you take a look at the schema of the Spark data frame now, you can see that it's actually a struct type, and there's a bunch of different stuff in here that SparkNLP has created. So if we actually explode that struct in Spark by running this little gnarly piece of code here, you can see that what it's done is it actually has different fields for how long the document is, the beginning index and the end. So this is the length of each document in characters. Then it has the actual text, and we have some stuff sort of here already as placeholders for metadata and embeddings, which we'll get to in a second. Okay, so that's just putting it in the standard form that SparkNLP expects to work with this document type. So now that we have our document, we can perform tokenization. Tokenization is a whole other topic in NLP, but for the simplest case of tokenization, you're really just using each word as a separate sort of unit of language, and word level tokenization is what you see a lot of the time. It's the simplest one to do. So to do that with SparkNLP, we import this tokenizer class from the annotator submodule. It's called annotator because really a lot of these classes, what they do is they add metadata to the Spark. They create metadata from the data that's in the Spark data frame. And then the code is basically exactly the same. The only thing that is different here, we set the input column, we set the output column. The only thing that is really different here is that we fit the tokenizer on the document data frame and then call transform on the document data frame. And now if you do that, we have our document data frame with a new column, which says token, and the token column also contains a structure. So if we use the same code as before to explode the token column, as you can see here, what is in that structure? Well, now you can see it's broken the different text documents down token by token, word by word. And now it has the starting index and ending index of each individual token within each document, right? So these tokens here, Elon Musk is a businessman, are in document 1, and then this here is document 2, and it has the start and end indices for each. Again, I'm doing this toy example, but you can imagine doing this over a very, very large corpus of text stored in whatever storage medium you have. Okay, and now we can apply an embeddings model to the text now that we have it tokenized, which is something that's a little bit more complex and data science-y like. Lots of different embedding models out there you can pick, lots of different options in SparkNLP. The default and simplest option is, as I mentioned, the GLOVE or Global Vectors for Word Representation embedding, which is just a statistical type of embedding that looks at the co-occurrence of words. So this is not so much really like more a model-based embedding, but there are model-based embeddings as well from deep learning models and things like that, and we'll talk about that in a sec. So here, looking very familiar now, just a few lines of code from the embeddings, word embedding submodule. There's a word embeddings model class. We instantiate that. Here, I actually specified to use the 100-dimensional GLOVE embedding in English, but this is the default. So if you just leave these parameters out and just put the parentheses, it will use that one as the default. And there are other embedding models you can pick as well. And then we set our document and token as the input columns, and then this new column embeddings as the output column. And now we don't fit it because the embedding model is already calculated. And we just call .transform. And you can see now that it actually has to download the embedding model. So here, the GLOVE 100D model is being downloaded. It's 145 megabytes in size. And I believe this is being downloaded from the SparkNLP model hub. Okay, so that is downloaded. You can see now that it has done the embedding. And now we have a new column, embeddings, that has been added to our growing Spark data frame. Okay, so let's take a look at what the embedding actually did. If we explode that embedding structure like we did before, we have the beginning and end of each token. We have the token itself. And now we have this new, I don't care about the metadata over here, but we have this new column embeddings, and it just looks like a bunch of numbers. So I'm going to pull out one of those by this piece of code here, exploding the embeddings column and then getting a result and subsetting and blah, blah, blah. So the token there from the first document, the first token is the word Elon. And then if you take a look at the embedding that is from that, the word Elon here, that is the token, but this vector here is the representation of that word Elon as a number in that 100-dimensional space. Okay, and that came from the embedding model. And you can see that if we take a look at the length of the embedding, it is 100 numbers in length, because that is a particular model we used to do the embedding for the text we have. So there are many, many different types of embedding models, with different dimensionalities. We happen to choose the very basic GLOV 100. So it's representing each token as a point in some 100-dimensional space. Okay, so now we have numbers. And we can actually do machine learning, apply a model, because we have text represented as numbers, and that is what computers understand. So we can apply our named entity recognition model. There is this NERD-L, which I believe stands for Named Entity Recognition and Disambiguation and Linkage Model class. So this is a class in SparkNLP for working with NERD models, of which I am one. But using it is very straightforward. Just like we saw before, we import the class from the NER submodule in Annotator. So here's the NERD-DL model. Then we instantiate the model. I've just put .pretrained here, and the default model that this uses, I believe, do I say what it is? Oh, the default model, oh, it's right here. The default model is one trained on the GLOV 100D embeddings. That's sort of the default. So if you don't specify the model type and you just use the default, make sure you're using the GLOV 100 embeddings, which are also the default, because that's what it was trained on. And then we put the document token and embeddings as input, and then we create a new output column called NER, and then we just call .transform on the embeddings data frame. And now the NER model will go through the data and perform the actual named entity recognition. And you can see it also has to download the model itself. This is only about 13 megs, but there is a saved named entity recognition model that we are using. So now we have this new data frame here. It's created this new column with a NER column. And if you take a look at that column, you can see that we now have different tags for each individual token. So this O tag just stands for other and means not an entity. And then you can see that Elon and Musk, this B stands for beginning and this I stands for inside. These two things are part of a named entity, but the model has incorrectly specified that Elon Musk is an organization, where it has identified that Joe Biden is a person and has identified that Sam Altman is a person. So there is our NER model in action, and there's a whole table here of the different types of things that the NER model can identify, and they each have sort of these different short forms or tags for recognizing them in text. Okay, so those were all the pieces to do named entity recognition with Spark, all the way from raw text up to the tagged sort of text that had the named entity recognition done. You probably wouldn't do all that if you're just trying to get some results so quickly. So we can actually put all these things together into a Spark NLP pipeline. So it's much easier to use these pipelines. You can build ones yourself and save them. But there's lots and lots of different pre-trained pipelines for doing different common tasks, including named entity recognition or other types of common tasks like matching patterns or classifying documents or doing sentiment or what have you. So very high level abstractions, but if you want to dive into each individual piece, like each model and document assembler and stuff like that, they are still contained within those pipelines. So now we can do that whole thing we just did with all those steps in literally like 2 lines of code from SparkNLP.pretrained, import pre-trained pipeline, excuse me. Then we create a pre-trained pipeline, and here there is this pipeline called Recognize Entities DL, and this is a pre-trained pipeline for doing entity recognition. It uses a slightly different model than the one we used before, but that's perfectly fine. And then you just call pipeline.annotate, and you are done. So that is all those steps together. All those things are in that pre-trained pipeline. Okay. And you can see it has to download the model and the embedding and stuff like that too. So it has to download 160 megabytes here. So now if I take a look at this result, just by running those couple lines of code, there is the data that has been created from doing that pipeline. And you can see that it's identified the different entities: Elon Musk, Joe Biden, and Sam Altman. Okay. And then if you want, you can plunk that into a pandas data frame, and it's a little nicer to look at, and there are our named entities. So that was very tough. That was 3 lines of code. What you may want to do, though, is actually visualize the result over a larger body of text, right? And actually show where the different entities are. This is a fairly common thing to do in NLP when you're doing NER. So there's this NER visualizer class. There's a whole submodule of SparkNLP called SparkNLP display. And then there's this NER visualizer, and it will do things like create nice visualizations like this that show you the different type of named entities that are tagged in a given piece of text. Okay, so Mona Lisa is a person, Leonardo is a person, the Louvre is a location, and so on. And so if you want to do that, you have to do a different type of annotation. So instead of calling annotate, you call pipeline.full_annotate, but I'm really not too worried. It's just 1 line of code that I need to run in addition. And now we get this larger structure of all the different annotations across our 3 sentences about where the named entities are and things like that. And then we can pass that result into the NER visualizer to get a visualization back. The NER visualizer does work 1 document at a time. So now, unfortunately, I do have to write a lot of code because I have to write a for loop to iterate over those 3 different sentences and then visualize each of them individually. So all I say here is from SparkNLP display, import NER visualizer, instantiate the visualizer, and then for each result from the annotated text, we just pass the result into the visualizer and then tell it what are the labels and what is the column that contains the document. And if you do that, now we get back visualization for each of our documents. You can see that it's labeled Elon Musk as an organization, Joe Biden as a person, and Sam Altman as an entrepreneur. And we have this nice visual there. So that's pretty neat. Okay, I'm going to take a drink of water. This model, this very simple model we used, it incorrectly identified Elon Musk as an organization. So the model's not perfect, and you can use different types of models and also different types of text embeddings, which may have better performance. So here we're going to use a different pipeline now, and there's this Onto Recognize Entities BERT Tiny pipeline, which is based on, instead of using the glove embedding, it's using the BERT embedding. And if you're familiar, BERT is one of the OG and most foundational large language models that came from Google. So here we're using an embedding that's based on an LLM instead, before we pass it into a named entity recognition model. But again, just very, very simple code. And really, there's a lot of abstraction here. I'm not claiming to do anything complex. And that pipeline is saved in the SparkNLP model hub. Okay, so now we run this different pipeline. A lot of stuff happened. I don't know exactly what it was. And now we can then, again, visualize the results. And you can see now that it's correctly identified that Elon Musk is a person, not an organization. So the BERT model with that pipeline, the BERT embedding, and that other model for NER in that pipeline did a better job. Okay. So yeah, nothing too complex. Didn't want to write a ton of code because I don't like doing it. But you can see with just a few lines of code here or there, you can create a Spark pipeline or use a pre-trained SparkNLP pipeline to do NLP type tasks. And obviously this is a very toy example, but you could apply these things to larger data sets as well. Okay, let me go back to, whoops. Let me go back to my other presentation here now. We're done the demo. Okay, so all of these models and pipelines are saved in the SparkNLP Model Hub. So I have a link to that here in the slides, and I actually do want to go to that. So here is a SparkNLP Model Hub. We were using pipelines and models from here, and you can search by the different types of tasks. You can see there's embeddings, there's things like sentiment analysis, spell checking, all kinds of different NLP tasks. And then there's also many, many different languages. So if you have a specific natural language processing use case in a particular language, then you can choose those. And you can just search for what you want to do. So lots and lots of different models here. Many of these are specialized for healthcare and medical type use cases, because that's what John Snow Labs and SparkNLP do a lot of. But I can search for something like the T5 LLM from Google. And if I search for that, you can see there are pipeline. Oh, it's right here, Google's T5. So here's a pipeline which is based on the T5 LLM from Google if you want to use that. Okay, and for many of these, especially the ones that come from John Snow Labs, they have nice demos, or they have Colab notebooks that demonstrate their usage to get you up and running. Okay, so that's the Model Hub. If you're not using a pipeline that's already there with these types of models and you want to do more cutting edge stuff with LLMs, as of quite some time ago now, SparkNLP does work together with the Transformers library from Hugging Face. It's been a while now. That update was from in 2021. So if you have a favorite model that is saved on the Hugging Face platform, you can now use it with SparkNLP through the SparkNLP and Transformers integration, which I think is pretty amazing to apply these types of models at scale. And they have an example of doing that here. There's a nice blog post about how to work with Hugging Face for state-of-the-art NLP with SparkNLP. And then other things that are new and coming in the recent future from John Snow Labs. We have another framework they're developing called LangTest. This is a different library separate from SparkNLP, more focused on working with large language models, more specifically focused on evaluation and alignment and bias and fairness and things like that of LLMs. But John Snow Labs is doing their best to develop this fairly comprehensive library for working with LLMs and doing evaluation of those. So it's kind of, they have like a testing harness and a bunch of other things. It works with Hugging Face and whatnot. But this is a fairly new thing that they started to work on recently, and it's a separate library. So you can look into that if you are interested. So I hope I have piqued your interest in doing NLP at scale. If you want to check out more things about how to work with SparkNLP, again, I don't work for John Snow Labs, but they have a lot of resources out there. They have a YouTube channel, they have Medium posts, and so on. What I would recommend as a good starting point would be to look at the official user guide and documentation. This is a good reference here, but another good place to start is if you go to their GitHub. They have a pretty extensive GitHub for SparkNLP, and in the examples folder here, there's lots and lots of different examples in Python for doing different types of things, including working with different transformers and LLMs, which is cutting edge, as I said. And then on top of those examples, they also have this SparkNLP workshop repo. And there's a number of different folders here of examples of workshops they've given. So if you want to do something like use SparkNLP in healthcare, they have a workshop here, and they have Jupyter notebooks for doing that type of thing. So lots of great resources here with a total cost of $0, which is my favorite. So I encourage you to check out these resources, and that's just on John Snow Labs GitHub. Okay, so I think we're at about time. That will about do it for me. Thank you very much for listening. I hope you enjoyed the presentation and learned something. Once again, the notebook is available. I put the link in the chat. I will also make the slides available through the Meetup. If you are interested in learning more about natural language processing and large language models and things like that, please check out NLP from Scratch at nlpfromscratch.com. Or if you want to connect with me or have other questions, you can connect with me on LinkedIn or reach me at my email, which is right there. Thank you very much.